All right, guys, 6.4 is a little bit shorter than 6.3, so we shouldn't take as long on these notes. But 6.4 is vectors and dot products. The dot product of two vectors. So far, you've studied two vector operations, vector addition and multiplication by a scalar. Each yields another vector. In this section, you will study a third vector operation, the dot product. This operation yields a scalar rather than a vector. So the definition of the dot product, turn this light off so there's not so much shadow. The dot product of U and V is U times V, which is actually U1, V1 plus U2, V2. There are 5 properties of the dot product. We're going to let U, V, and W be vectors in the plane or in space, and let C be a scalar. So U times V is the same thing as V times U. Zero times V is 0. U times V plus W is equal to U times V plus U times W. The fourth one, V times V is equal to the magnitude of V squared. And then C times U times V is equal to CU times V, or U times CV. So how do you find dot products? You again just follow those rules up there. So U times V is U1 V1 plus U2 V2. Now remember, it's going to be a scalar, so it's going to come out to one single number. So this one is 4 times 2 plus 5 times 3. 4 times 2 is 8. 5 times 3 is 15, and then 8 plus 15 is 23. The next one, 2 times 1 plus -1 times 2 gives you 2 minus 2, or 0. And then the last one, 0 times 4 plus 3 times -2 gives you 0 plus -6, or just -6. So again, dot products just following that little rule that I wrote above. Using the properties, those 5 that we just saw, let U equal -1, 3, V equal 2, -4, and W equal 1, -2. Use these vectors and the properties of dot product to find each quantity. So U times VW, we're going to multiply U times V. So we're going to start right here. Our U is -1, our V is 2, plus 3 times -4. So again, multiply your x's added to multiply your y's. You get -2 minus 12 or negative 14. And then you're going to multiply that by your W. And remember, when we multiply from the last unit or from the last section, we're just going to distribute that in. So negative 14 times 1 is negative 14. Negative 14 times 2 is 28. U times 2V. We have U is negative 1, 3. We have to do 2V. V is 2, negative 4. We're going to distribute this 2 in, leaving this U alone. And we get 4, negative 8. And then our property says multiply your x's, add, multiply your y's. So negative 1 times 4 and 3 times negative 8 gives you negative 4 minus 24, which is negative 28. This next one has the magnitude of U. If we pull back up for just a minute, right here is the only one with a magnitude that says if you square it, you actually get V times V. So we're going to square this. Will give us U times U. So U is negative 1, 3. Sorry. And we're going to multiply that together. So we get negative 1 times negative 1 plus 3 times 3, which gives us 10. But that is the magnitude squared. So to get rid of that square, so again, magnitude squared equals 10. We're going to take the square root. So just the magnitude is the square root of 10. Right. The angle between two vectors, the angle between two non-zero vectors is the angle theta. And theta falls between 0 and pi between the respective standard position vectors. This angle can be found using the dot product. Again, the angle between two vectors, if theta is the angle between two non-zero vectors, U and V, then cosine theta equals U times V over the magnitude of U times the magnitude of V, kind of like the other formula that we had. Right. So find the angle between U is 4, 3 and V is 3, 5. So cosine theta equals, remember to do U times V, that's what we did on the front page. We're going to do our x's multiplied together plus our y's multiplied together. And then to find your magnitude of U, it's that distance formula. We're going to use 4 and 3, but then you also have the magnitude of V. So we're going to use the 3 and the 5. On the top, 4 times 3 is 12. 3 times 5 is 15. On the bottom, 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. 3 squared is 9. 5 squared is 25. 25 plus 9 is 34. And then we're going to simplify it. 12 plus 15 is 27. The square root of 25 is 5. Square root 34. So I still haven't found the angle. I've just found what cosine theta is equal to. So remember, to actually be able to find the angle, we're going to do cosine inverse of 27 over 5 square root 34. Pull that calculator up for you. On this one, it wants radians. So I switched my calculator to radian mode. 27 over 5 square root 34. And you get 0.3869. 0.3869. And remember, that's radians. Okay. Find the angle theta between you. If you wanted to find degrees, just switch it to degree mode. That's fine. They'll specify which one. So find it between you is 2,1 and 1,3. So I'm going to try to keep this one up here so we can look at it. So we're going to do cosine theta equals, we're going to multiply these together. 2 times 1 are your x's, plus 1 times 3 are your y's. Your magnitudes, 2 squared plus 1 squared, and then 1 squared plus 3 squared. 2 times 1 is 2, 3 times 1 is 3. 2 squared is 4, plus 1 squared is 1, 4 plus 1 is 5. 1 squared is 1, 3 squared is 9, add them, we get 10. 2 plus 3 is 6. Neither one of these will simplify, so we just multiply them together. However, your 50 will simplify. 50 is 25 and 2. The square root of 25 is 5. You would leave a 2. They don't like the square root in the bottom, so they multiply it out. We get 6 square root of 2 over 5 times 2 is 10. I'm sorry, 2 plus 3 is 5. That makes a big difference. And those will cancel out to be 1, which gives you square root of 2 over 2. I apologize, Shell. 1 times the square root of 2, and then square root of 2 times square root of 2 is 2. You have cosine theta equals square root of 2 over 2. Remember, to find theta, you do cosine inverse of square root of 2 over 2. When you put that in your calculator, you get 0.7854 radians. Again, if you want to change it to degrees, we should know what this is using our unit circle, but it will give you 45 degrees. Again, I don't care which one you give me, radians or degrees. Rewriting the expression for the angle between two vectors in the form u times v equals the magnitude of u times the magnitude of v cosine theta. So I'm going to explain this real fast and give you a minute to copy it down. All they did was take this formula from up here and get rid of this denominator. So how do we get rid of the denominator? We multiply cosine theta by the magnitude of u, magnitude of v, and that's what they did right here. Okay. It produces an alternate way to calculate the dot product. From this form, you can see that because the magnitude of u and the magnitude of v are always positive, u times v and cosine theta will always have the same sign. The 5 possible orientations of two vectors are shown below. I'm going to draw these out, don't flip yet. So the first one that you have looks like this. This is going to be your angle. Theta is going to equal pi, or even 180 degrees. Because again, if you're going through the unit circle, this is 0 pi over 2 pi, or it's at 180 degrees. Cosine theta will equal -1, and they're going in opposite directions. Your next one. Here's U and V and theta. This angle is greater than 90 degrees. So it is found between pi over 2 and pi. So remember, pi over 2 is your 90 and pi is your 180. So that means that cosine will be between -1 and 0. Again, here's why. Remember, cosine is your x coordinate. So over here, our x coordinate was -1 because of -1, 0. Here we have 0, 1 to -1, 0. So your x coordinate is from 0 to -1, or if you put it in the correct order, -1 to 0. So that's where that little evaluation is coming from, and it's an obtuse angle. The next one is it's directly 90 degrees. Directly 90 degrees. And I'll put a little box in here just for you guys so you can see that it's 90 degrees. So this 90-degree angle, remember this is 0 radians or 0 pi. This one is pi over 2. So this angle is found between 0 and pi over 2. Your coordinate is 1, 0 and 0, 1. So your x's go from 0 to 1. So your cosine theta will be between 0 and 1. I'm sorry. Sorry, I was doing the next one. Theta will actually be pi over 2 because it's exactly 90 degrees, which means that your x coordinate is 0 for a 90-degree angle. I apologize, y'all. I am so sorry. I was writing for this one. Theta, U, and V. This one is the one between 0 and pi over 2. And cosine will be between 1 and 0 or 0 and 1 because this is an acute angle. All right, and the last one is going to look like this. You're actually going to have an angle on top of itself. So the little part is going to be V, we're going to call it V, and the full length we're going to call U. Theta is going to equal 0 because we didn't go anywhere. Our coordinate for our unit circle is 1, 0, so cosine theta will equal exactly 1, and these go in the same direction. All right, again, sorry I messed up that one. I just got ahead of myself. All righty, excuse me. Definition of orthogonal vectors. The vectors U and V are orthogonal if and only if U times V gives you 0. The terms orthogonal and perpendicular mean essentially the same thing, meeting at right angles. Note that the zero vector is orthogonal to every vector u, because 0 times u is going to be 0. All right, so it says, are the vectors u and v orthogonal? The way that you tell is you multiply them, and if they give you 0, you know that they are. So we're going to take 2, -3, and we're going to multiply it by 6, 4. Remember, we learned how to multiply our x's together plus multiplying our y's together. We get 2 times 6 is 12. -3 times 4 is -12, which gives us 0. So are they orthogonal? Yes. Doing the same thing on the next one. 6, 10, -1/3 and 1/5. We're going to multiply them. 6 times -1/3 plus 10 times 1/5. 6 times -1 is -6 divided by 3 is -2. 10 times 1 is 10 divided by 5 is 2, which gives you a 0. So yes, they are orthogonal. Finding vector components. You have already seen applications in which two vectors are added to produce a resultant vector. Many applications in physics and engineering pose the reverse problem, decomposing a given vector in the sum of two vector components. Consider a boat on an inclined ramp. The force F due to gravity pulls the boat down the ramp, so like towards the water, and against. So that's why we stay on earth, like actual feet touch the ground. It's because gravity pulls us to the ground, against the ramp. These two orthogonal forces W1 and W2 are vector components of F. That is, F is equal to W1 plus W2. The negative component W1 represents the force needed to keep the boat from rolling down the ramp, whereas W2 represents the force that the tires must withstand against the ramp. A procedure for finding W1 and W2 is shown below. So definition of vector components. Let U and V be non-zero vectors such that U equals W1 plus W2, where W1 and W2 are orthogonal, and W1 is parallel to, or a scalar multiple of, V. The vectors W1 and W2 are called vector components of U. The vector W1 is the projection of U onto V and is denoted by W1 equals, they literally start spelling out projection, PROJ sub V U, kind of like a log base 2 of 4. So that V kind of looks like that. The vector W2 is given by W2 equals U minus W1. So give you a minute to finish that up. Again, we're almost done, guys. Sorry, W2 equals U minus W1. The projection of U onto V, let U and V be non-zero vectors. The projection of U onto V is, so here's where they define it for you. So the projection of U onto V is that same formula that we just did a little bit ago. We're doing U times V, but this time we're doing it over the V magnitude squared times V. All right, so we're going to find the projection of U onto V, then write U as the sum of two orthogonal vectors, one of which is the projection of U onto V. So we're going to start by doing W1. W1 is U times V over the magnitude of V squared. So U times V, remember when we multiply these, your X's come first, X's multiplied together, plus your Y's multiplied together. This is the magnitude of V squared. So what that's gonna do is we're gonna do 6 squared plus 2 squared. But when we square that, it just cancels out the square root. So on the top, we have 18 minus 10. On the bottom, 6 squared is 36. 2 squared is 4. When we add that up, we get 40. 18 minus 10 is 8 over 40, or 1/5. Now you take that 1/5 and you multiply it by V. So this is what we just did, this set of parentheses right here. We're going to multiply it by V. And we get 6/5, 2/5. So that's your W1. Now we need to find our W2, which is U minus W1. So our U was 3, -5, minus our W1, 6/5 and 2/5. You can do these in your calculator. 3 minus 6/5, you can get a common denominator would be 5. 3 times 5 is 15, minus 6 is 9 over 5. Same thing here, -25 minus 2 is -27 over 5. Worst case, again, do that in your calculator. So it says write U as the sum of two orthogonal vectors, one of which is projected U onto V. So U is going to equal W1 plus W2. W1 was 6/5, 2/5, plus W2 is 9/5, -27/5. And when we add that up, 6 plus 9 is 15 divided by 5 is 3. 2 plus -27 is -25 divided by 5 is -5. So here is the sum of the two orthogonal vectors. Here is your projection. So this one equals the projection of U onto V. Finding force. A 200-pound cart sits on a ramp inclined at 30 degrees as shown below. What force is required to keep the cart from rolling down the ramp? So F is negative 200J. To find our V, remember we do cosine theta I plus sine theta J. Our theta is 30 degrees. So cosine 30 times I plus sine 30 times J. Cosine 30 is the square root of 3 over 2. That's going to go with I. Sine 30 is 1/2. That's going to go with J. And again, these come from the unit circle, the X coordinate of 30, and then the Y coordinate of 30. Now we need to find W1. Why do we have to find V? We've got to do this formula up here. So now we need to find W1, which is the projected force onto V. Which would be F times V over the magnitude of V squared times V. So your F, if you go back up here, it did not have an X coordinate, but it had a Y coordinate of negative 200. So when we do F times V, we're going to use this vector. And then your X coordinate here is square root of 3 over 2 and 1/2. So those are the ones that I'm multiplying together on the top of here. So 0 times square root of 3 over 2 plus negative 200 times 1/2. Your V is this one. So remember your square root's going to cancel out. So all we're doing is the square root of 3 over 2 squared plus 1/2 squared. These will cancel out. On the top, you're going to get negative 100. On the bottom, you get 3/4 plus 1/4, which is 4/4 or 1. So then there is your force. Also, we can rewrite this with our trajectory up here. Square root of 3 over 2I plus 1/2 J. But again, remember that outside number is your force. So your force is negative 100. One more definition, one more problem. Definition of work. The work W done by a constant force F as its point of application moves along the vector PQ. Back to writing that vector. Is given by either of the following. Work, or W, is going to equal the magnitude of the projected force onto that vector times the magnitude of the vector. Or W is going to equal the force times the vector. All right. So finding work. To close a sliding barn door, a person pulls on a rope with a constant force of 50 pounds at a constant rate of 60 degrees as shown below. Find the work done in moving the barn door 12 feet to its closed position. So I'm gonna redraw this for you for just a minute so that you guys can see that. Don't judge my drawing skills. This is Q, P. This angle is 60 degrees. So you got a little man with extremely long arms pulling on this rope. And we're trying to close it 12 feet. This is the force that the man is using to pull down. This is the projected force on the vector of that barn door sliding. Okay, so this is the figure that's here that you can sort of see. If you squint really hard, you can see it. Okay. So W equals the magnitude of the projected force onto the vector PQ times the magnitude of PQ It says to close the sliding barn door, a person pulls on a rope with a constant force of 50 pounds. 50 pounds. So we have cosine 60. That's your degree. Why did we use cosine? Because we have the adjacent and the hypotenuse. Adjacent and hypotenuse. We're going to multiply that by F. And PQ is magnitude. Cosine of 60 is going to be 1/2. The force of the door, it told you, was 50. And then we're moving it 12 feet. So remember, these are all distances. 50 is a distance, and then your 12 is that distance. When we multiply this together, we get 300. So the work done is 300. All right. That is it for 6.4. If you guys will go on Canvas, you'll see what your homework should be. Thanks, guys.